1982 Memo to Exxon Management about CO2 greenhouse effect. November 12, 1982 Exxon's MB Glaser, manager of the Environmental Affairs Program, sends a memo to Exxon Management on the CO2 greenhouse effect intended for the management staff to familiarize themselves with the subject. Glaser includes the April 1, 1982 CO2 greenhouse effect, technical review report. In Glaser's summary to management, he writes that the carbon dioxide concentration in the atmosphere now stands at 340 ppm and that fossil fuel combustion along with clearing of virgin forests are the contributions to the trend. Glaser writes, "Our best estimate is that doubling of the current concentration could increase average global temperature by about 1.3 degrees Celsius to 3.1 degrees Celsius. Glaser acknowledges that there is considerable uncertainty about the impact this warming will have on society and that there is currently no unambiguous scientific evidence that the Earth is warming. Glaser writes that greenhouse effect could be detected by 1995 or 2020 if the climate models are exaggerating. Glaser writes that mitigation of the greenhouse effect will require reductions in fossil fuel combustion, and that the warming might not be reversible." On page A15, Glaser calculates the total carbon dioxide emitted from burning primary fossil fuels. An Exxon memorandum reading by robot follows this introduction to climate-related ideas. Increase your climate literacy. Anthropogenic means human-caused. Noise level means the variable, the different temperature measurements that bounce up and down in any one year, decade, or century. Global warming causes climate change. Global cooling also causes climate change. Like many others, Exxon's executives know that carbon dioxide, CO2, causes global warming. China. At the writing of the below Exxon memorandum, China was just entering the Industrial Revolution in a serious way. Carbon dioxide, CO2, increased dramatically in Earth's atmosphere and oceans as a result, more rapidly than the author of this document expected. Hardly worth the gamble. Climate models. Climate models are not exact, they will never be exact. They give us a trend, an expectation of what to expect as proven by historical trends. For example, heart monitors do the same just as economic models do the same. What they knew, when they knew. If you are new to this line of information, what they knew and when they knew, you may not fully comprehend its meaning at first. Exxon did not know how bad it was going to be, but it knew it was going to be bad. How much it chose to gamble appears to be the whole pot, Earth's planetary health for countless generations. Ironically, it gambled with resources extracted from U.S. fossilized materials to burn for its own profit at humanity's expense, short-term profits at long-term costs, externalizing the costs of business. Cable, Exxon, NY. November 12, 1982. Greenhouse effect. F. L. Weinberg. November 15, 1982. 2. See distribution list attached. Attached for your information and guidance is briefing. Material on the CO2 greenhouse effect, which is receiving increased attention in both the scientific and popular press as an emerging environmental issue. A brief summary is provided along with a more detailed technical review prepared by CPPD. The material has been given wide circulation to Exxon management and is intended to familiarize Exxon personnel with the subject. It may be used as a basis for discussing the issue with outsiders as may be appropriate. However, it should be restricted to Exxon personnel and not distributed externally. Very truly yours, MB Glaser. Greenhouse effect. Propitiatory. Summary. Atmospheric monitoring programs show the level of carbon dioxide in the atmosphere has increased. Summary. Atmospheric monitoring programs show the level of carbon dioxide in the atmosphere has increased about 8% over the last 25 years and now stands at about 340 ppm. This observed increase is believed to be the continuation of the trend which began in the middle of the last century with the start of the Industrial Revolution. Fossil fuel combustion and the clearing of virgin forest, deforestation, are believed to be the primary anthropogenic contributors, although the relative contribution of each is uncertain. The carbon dioxide content of the atmosphere is of concern since it can affect global climate. Carbon dioxide and other trace gases contained in the atmosphere such as water vapor, ozone, methane, carbon monoxide, oxides of nitrogen, etc. absorb part of the rays redirected by the Earth. This increase in absorbed energy warms the atmosphere, including warming at the Earth's surface. The phenomenon is referred to as the greenhouse effect. Predictions of the climatological impact of a carbon dioxide-induced greenhouse effect draw upon various mathematical models to gauge the temperature increase. The scientific community generally discusses the impact in terms of doubling of the current carbon dioxide content in order to get beyond the noise level of the data. We estimate doubling could occur around the year 2090 based upon the fossil fuel requirements projected in Exxon's long-range energy outlook. The question of which predictions and which models best simulate a carbon dioxide and is climate change is still being debated by the scientific community. Our best estimate is that doubling of the current concentration could increase average global temperature by about 1.3 degrees Celsius to 1.3 degrees Celsius. The increase would not be uniform over the Earth's surface, with the polar caps likely to see temperature increases on the order of 10 degrees Celsius and the equator little, if any, increase. Considerable uncertainty also surrounds the possible impact on society of such a warming trend, should it occur. At the low end of the predicted temperature range, there could be some impact on agricultural growth and rainfall patterns, which could be beneficial in some regions and detrimental in others. At the high end, some scientists suggest there could be considerable adverse impact, including the flooding of some coastal land masses as a result of a rise in sea level due to melting of the Antarctic ice sheet. Such an effect would not take place until centuries after a 3 degrees Celsius global average temperature increase actually occurring. There is currently no unambiguous scientific evidence that the Earth is warming. If the Earth is on a warming trend, we're not likely to detect it before 1995. This is about the earliest projection of what the temperature might rise, the 0.5 degrees needed to get beyond the ranges of normal temperature fluctuations. On the other hand, if climate modeling uncertainties have exaggerated the temperature rise, it is possible that a carbon dioxide-induced greenhouse effect may not be detected until 2020 at the earliest. The greenhouse effect is not likely to cause substantial climatic changes until the average global temperature rises at least 1 degree Celsius above today's levels. This could occur in the second or third quarter of the next century. However, there is concern among some scientific groups that once the effects are measurable, they may not be reversible and little can be done to correct the situation in the short term. Therefore, a number of environmental groups are calling for action now to prevent an unbearable future situation from developing. Mitigation of the greenhouse effect would require major reductions in fossil fuel combustion. Shifting between fossil fuels is not a feasible alternative because of limited long-term supply availability for certain fuels, although oil does produce about 18% less carbon dioxide per BTU of heat released and coal, and gas about 32% less in oil. The energy outlook suggests synthetic fuels will have a negligible impact at least through the mid-21st century, contributing less than 10% of the total carbon dioxide released from fossil fuel combustion by the year 2050. This low level includes the expected contribution from the carbonate decomposition which occurs during shale oil recovery and assumes essentially no efficiency improvements in synthetic fuels processes above those currently available. Overall, the current overlook suggests potentially serious climate problems are not likely to occur until the 21st century or perhaps beyond, and projected energy demand rates. This should provide time to resolve certainties regarding the overall carbon cycle and the contribution of fossil fuel combustion, as well as the role of the oceans as a reservoir for both heat and carbon dioxide. It should also allow time to better define the effect of carbon dioxide and other infrared absorbing gases on surface climate. Making significant changes in energy consumption patterns now to deal with this potential problem amid all the scientific uncertainties would be premature in view of the severe impact such moves can have on the world's economies and societies.